Welcome to the Deep Dive. Today, we're getting into something really fundamental. We're looking at how these incredibly smart large language models, the LLMs we use all the time, actually learn to be, good or helpful.
Right.
We're talking about their internal compass, these things called reward models or RMs. This is how the AI figure out what we humans actually prefer.
It's a concept that's, way more critical than most people probably realize. These RMs are absolutely foundational in the AI training pipeline, especially when you talk about reinforcement learning from human feedback. RLHF.
RLHF.
If you picture RLHF, it's basically this feedback loop, right? The AI generates something, a human gives it a thumbs up or down, essentially, and the reward model learns from that pattern.
Okay.
That's how the AI starts to internalize what good looks like to us. It guides it toward better behavior. Without a decent RM, an LLM just, it can't really align with what we actually want.
And that's our mission today, really, to unpack this seemingly groundbreaking new paper from Skywork-AI. They put together this huge new data set in what looks like a genuinely new way to teach AI what good means. We're going to explore how this human-AI synergy they talk about is maybe fundamentally changing things for AI alignment and how well these models perform. It feels like it could be a big deal.
It really could be. And what's so interesting is that even though these RMs are so vital, the ones we've had, especially the open ones, often just fall short. They tend to be brittle.
Subtle.
Yeah, meaning they kind of break easily when faced with real-world complexity. They struggle to capture the, nuanced and sophisticated human preferences that are so important for an AI that's genuinely helpful. It's like trying to navigate London with a map of just the tube. You miss a lot.
So this brittleness, that sounds like a core issue. What's surprising about that, though? I mean, with all the money pouring into AI, why are the datasets the weak link? The paper suggests exactly that, doesn't it? That the brittleness stems primarily from limitations in preference datasets.
It does.
These datasets that are meant to teach preference are often too narrowly scoped, or maybe synthetically labeled, or they just lack rigorous quality control. You'd think we'd have nailed this by now with all the fancy training techniques.
It is a bit surprising, yeah. Because the problem isn't always the algorithm, it's the ingredients, the data itself. And this feeds right into that issue of benchmark over-optimization. Think about reward bench. It became the standard test for RMs for a while. So models got really, really good
at passing the test.
Exactly. They aced reward bench. But then in the real world, the performance didn't necessarily improve alongside it. We saw studies showing weak or even inverse correlations between scores on that benchmark and how well the models actually performed on downstream tasks.
Classic teaching to the test, then.
Totally.
So they looked great on paper, acing the exam, but weren't actually getting smarter or more aligned where it counts. I saw the source mention that reward bench scores basically hit a ceiling, they saturated, but scores on newer, tougher benchmarks barely budged. It's like they got stuck.
Yeah.
Right? The benchmark wasn't pushing them in the right ways anymore.
Precisely. And that led to this period where things felt stagnant. For a while, maybe starting around September 2024, progress in open data sets and RMs really seemed to slow down. You saw a lot of the top models using the same basic data or stuff that was very similar.
Which makes you ask that big question.
Yeah. Are we just training models to pass tests we design, or are we actually training them to understand the messy, complex reality of human preferences out there?
So, okay, the field needed a shakeup. A new approach to the data problem. And that's where Skywork-AI comes in with SynPref 40M. Tell us about this. 40 million pairs. That sounds enormous.
It is enormous. SynPref 40M is their big answer. 40 million preference pairs. And to build it with quality, they came up with this really interesting human-AI synergistic two-stage pipeline.
Human-AI synergy.
The whole idea is leveraging the best of both worlds. The complementary strength of human annotation quality and AI scalability. Humans are good at nuance, AI is good at scale. Combine them.
Okay, that makes sense conceptually. How does it actually work on the ground? Stage one is the small-scale, human-in-the-loop curation. That sounds like where the people come in.
That's exactly right. Stage one is all about getting that initial high quality. Humans provide verified annotations, and they follow a really stringent protocol for quality assurance.
So not just clicking buttons.
Definitely not. Annotators are encouraged to use external tools, things like search engines, other powerful LLMs, even domain-specific models to help them make informed judgments. But, and this is key, full reliance on LLMs for labeling is strictly prohibited. The human makes the final call. That's where you get that deep understanding.
That's a smart mix. And they're capturing more than just good or bad, right?
Mm-hmm.
I saw something about LLM-generated preference attributes like task category, objectivity, controversiality, metadata, basically.
Exactly. That metadata helps guide the humans, ensures they're looking at a diverse range of examples, and helps structure the whole process. And then there's this iterative refinement part, which is pretty clever.
Okay, tell me about that.
They start by training an RM on what they call silver data. That's data that's been pre-verified by an LLM faster, but maybe less reliable at first.
Right.
Then they test that RM on the gold data, the stuff meticulously verified by humans. That's the benchmark.
The ground truth.
Exactly. If the RM messes up on certain types of examples in that gold set, they use that information. They adaptively find simile samples in the larger pool and send those for human re-annotation.
Ah, so it's a feedback loop.
It's a continuous feedback loop, constantly folding that human quality check back into the process, improving the model and the data curation over time. It's a really dynamic blend of human insight and AI scale.
That sounds incredibly effective for quality control. So stage 1 nails the quality with human input. But 40 million pairs. Humans can't verify all that. How do they get to that huge number? That must be stage 2. Large-scale automatic curation.
You got it. Stage 2 is where the AI takes over for sheer volume. It scales data curation automatically using reward model consistency checks.
Okay, what does that mean, consistency checks?
Basically, once they have a pretty good RM trained on the high-quality stage 1 data, they can use that RM to evaluate new unlabeled pairs. If the RM is highly confident about which response is better in a pair, and this aligns consistently with other checks, they can automatically accept that label without needing a human to look at it again.
So it leverages the model they already built.
Precisely. It eliminates the need for further human supervision for millions of pairs. They mentioned about 5 million preference pairs pass through this automatic check. It's how they scale up efficiently while still having confidence built on that solid stage 1 foundation.
And didn't they have another trick? Something about recycling data.
Ah, yes. That was quite neat. They took pairs that were initially discarded, maybe because the RM wasn't sure, or it got it wrong early on. Later, if their improved RM becomes highly confident that the rejected response was indeed worse, they can essentially flip the label.
So the originally chosen one becomes the better one in a new pair with the discarded one?
Exactly. It incurs no additional annotation or computational overhead, but gave them consistent performance gains. It's a really pragmatic way to squeeze more value out of the data they already processed. Very efficient.
Okay, so they built this massive, carefully curated dataset with this two-stage pipeline. What's the payoff? They introduced the Skywork-Reward-V2 models. How good are they? Are we talking genuinely state-of-the-art?
Well, the results look pretty stunning. The suite has 8 reward models, ranging in size from 0.6 billion parameters up to 8 billion. They trained these on a curated subset of about 26 million pairs from SynPref 40M, plus those extra 14 million flipped pairs for the full 40M effect.
And the performance.
State-of-the-art. Across 7 major reward model benchmarks. That includes the old reward bench, the newer reward bench V2, PPC preference, PPE correctness, RMB, RM bench, judge bench. Basically the works.
Wow, okay. What really jumped out at me, though, was the versatility and this idea about model size. The paper says these RMs work well across general human preferences, objective correctness, safety, resisting stylistic biases, even something called best-of-n scaling. But the kicker.
The kicker is that even their small 1.7B variant surpasses the best existing 70B reward model on average.
Right. A 1.7B model beating a 7DB model. That just completely flips the script on bigger's always better, doesn't it? What does that mean for, like, making good AI more accessible?
It's huge. It really underscores that data quality, the right data, can trump sheer parameter count. Their 8B model actually ranks first on all 7 benchmarks among open RMs. They also showed it has superior capability and precise instruction following.
Better than some big names, apparently.
Yeah, reportedly outperforming strong proprietary models like versions of Claude 3.7 Sonnet and Gemini 2.5 Flash, plus a significant increase in the factuality score. That's massive for trust and reliability. It really shifts the focus, doesn't it? From just scaling up compute to scaling up data intelligence.
Hugely compelling. But,
Yeah.
you always wonder, is it just a really good data set, or is the method the key? Did they do ablation studies to prove it was their curation process? What did they find about quality versus just dumping in more raw data.
They did, and the ablations really back up the quality over quantity idea, at least for uncurated data. They found that increasing the amount of uncurated data results in minimal performance gains.
Really? Even adding millions more pairs?
Yeah, even adding 12 million more raw pairs barely moved the needle, didn't even surpass their initial seed model performance, but contrast that with the curated data, adding more of that showed consistent performance improvements. It's like try to build a skyscraper. Adding more low-quality crux won't help if the foundation and the core materials aren't good.
That paints a clear picture. And the impact of the curation itself, the quality boost, sounds incredible. They said training on just 1.8%, like 290,000 samples of their curated set,
Was enough to surpass the previous state-of-the-art, which was a 70B model, even when Skywork used their smaller 8B scale model.
That's just wild efficiency, purely from getting the data right.
It really is, and they broke down the curation benefits too, just using simple LLM filtering barely improved things like 0.1 points. But the largest improvement comes from human curation, a 2.3-point gain over their starting baseline.
Wow.
It hammers home that while AI can help with scale, that human judgment, that nuanced understanding, it's still absolutely critical for those big leaps in quality. The human touch isn't optional for top-tier performance. It seems essential.
And using the full protocol, giving humans those external tools that pushed it even further.
Yes, the full annotation protocol delivered the best results, a 3.2-point improvement. It shows that empowering the human annotators, giving them the resources to make really solid judgments, pays off directly in model performance. Even that adaptive retrieval idea boosted the LLM curation part by nearly a point, just by feeding the AI better examples identified through the human feedback loop.
It really feels like a testament to designing the whole system well, the human part and the AI part working together.
Definitely. But looking ahead, it's not like all problems are solved, right? There are still big questions. Human preferences themselves are messy. They're inherently diverse, often conflicting, sometimes ambiguous, subjective, or context-dependent.
Yeah, that's true. We don't all agree on everything.
So can one single reward model, even a really good one, truly capture all of that complexity? Or do we eventually need, I don't know, multiple RMs or context-aware RMs or personalized RMs? It's a huge open question.
That is a deep question. Trying to boil down all human values into one AI compass. Tricky. What about the pipeline itself? Are there limitations or areas for future work there?
For sure. That recycling trick with the discarded data, they admit it's purely empirical right now. It works, but they need to dig more into why it works consistently.
Yeah.
And any pipeline relying heavily on LLMs is going to inherit some potential biases and modeling errors. That's just unavoidable right now. Plus, they noted that getting satisfactory results from fully automatic curation alone, without the human-in-the-loop stage, just wasn't feasible with current LLMs.
Why not?
Mostly inference costs and API limitations. It's just too expensive or slow right now to have an LLM do that super high-quality check on millions and millions of pairs completely automatically. But that points to a future direction, right? Maybe next-gen LLMs could handle more of it.
Interesting. So this all brings us back to the central point, really. Reward models are becoming maybe the most, if not the only, critical components of today's LLM training pipeline. That's a strong statement.
It is.
They're not just grading the AI's homework anymore. They're framed here as the very compass by which intelligent systems navigate complexity, align with human values, and continually evolve toward ever more meaningful objectives. That's quite a promotion for the humble RM.
It absolutely is. And this Skywork research feels like a really significant data point, showing a concrete path toward making that compass much more accurate, much more aligned, by cleverly combining human smarts and AI scale.
So let's try to wrap this up. The big takeaway seems to be that building AI we can trust, AI that's genuinely aligned with us, depends massively on the quality and the intelligent curation of the preference data we feed it. Raw quantity isn't enough.
Not by itself, no.
In Skywork's approach, this human-AI synergy shows a powerful way forward. It proves that smart curation, blending human insight with AI efficiency, can yield huge gains, even allowing smaller models to outperform much larger ones.
It really makes you think about where this is all heading.
It does, and here's maybe a final thought to leave everyone with. If these AI systems are getting more capable, more agentic, tackling complex stuff, what does it really mean for the compass guiding them, the reward model, to be something we're still actively refining, something that still seems to need deep human insight to get right? What doors open up when AI can truly grasp our nuanced preferences, moving beyond just gaming a test to actually embodying our values, it feels like we're just scratching the surface of what that partnership could unlock.